his second experiment, he burned wood in a closed system, so nothing could escape, no gas or nothing could go in either. And he burned it, he weighed it before he burned it, and then he weighed it after. And it weighed the same amount as it weighed before.
So I don't understand. So if you burn this right here inside a closed box,
Or something where nothing could get out or in.
where nothing could get out, it was a metal box, and you burn this, although you would need oxygen for the fire to burn, but just say you had it. This would weigh the same burned as if you, as like this in the box.
Yeah,
Would it be the same weight?
This
Mm-hmm.
this would not be the same.
Physical would change.
It's a chemical change.
So it's a chemical change, so but physically it wouldn't be the same thing. So it would be, it's a chemical change though.
This exact thing would not be the same because the gases that were like inside of it will come out, and that will weigh.
That weight, so the gases actually have weight.
Yes.
Oh, okay.
Well, they don't have weight; they have mass,
Okay.
and mass is different. And so, so do you understand what he did in that experiment?
Yes.
Okay.
I understand, but, so I thought it was that the weight would be the same, but the mass of it is the same. So it's the same amount of mass, okay.
Yeah.
Okay.
And so his experiments were different from others because the alchemists, who are a different type of scientists, they would do experiments like trying to turn metal into gold, and they would do this by doing random things with, like, they'd get like acid or something and pour it onto a metal, see if it would turn into gold, and they weren't really very successful. Or they would try and create elixir, which would give you eternal life, and they would like mix a bunch of liquids together or something to try and get you the elixir to get you eternal life.
So, so the alchemists were amateur scientists? Or were they scientists? They just didn't do controlled experiments.
Yeah, they couldn't really as easily repeat those experiments. Lavoisier, he was perfectionist. He would recreate experiments 100 times if he had to. And
Doing things exactly the same way every
exactly the same way, and he had the materials because all his money from when he was a tax collector, he'd spend that on the nicest measuring tools, like the nicest scales and everything, to make sure he had the exact same results every time. So that's how and then he proved them wrong by the law of conservation of mass, because you can't, like, that kind of cancels out everything. And do you get how that doesn't really work? That you can't change something.
You can't change the mass of something?
Yeah, because like I'm sure gold weighs something else from different metals, and you can't really change that. So
That makes sense, yeah.
yeah.
The amount of mass makes sense. Did you talk about the people who were?
Yeah, and he knew a lot of people. He knew lots of people. Like, he would entertain. He liked to have dinner parties and with the king, and with the king, he would entertain him. And he made this thing for the king. Instead of using candles, he'd use all vinegar oil because it was more effective in the streets, to light the streets up at night. And
Did they used to use candles before that, or?
yeah, torches maybe.
Okay.
And yeah, the king asked him to do this
So why did the king want him to do it? Did he want something that was like
more
burned?
efficient.
Okay, slower burning and wouldn't.
Yeah, it's more efficient.
Okay.
Kind of.
Yeah.
And he was called the father of chemistry because he created this big law which allowed science to move forward. So people weren't stuck trying to turn like metal into gold. So science could move forward.
So what's the law he created?
The law of conservation of mass.
Oh, okay.
Yeah, and do you know how this could relate to the real world?
It seems like it might relate with tides and the way maybe tides are coming in and out, and that the mass is still the same, it's just moved to a new place. Or sometimes that, the lake will go down a foot, Lake Michigan might go down a foot, different years, but then it seems to come back up. So maybe, the water's still there, it's just in a different place.
Mm-hmm. Yeah. Some clouds maybe
Could be, yeah, or could, yeah.
be in the sand. Under. And well, another way is pollution. So if you burn garbage, you might say, oh, it just disappears and it goes away. But really, it turns into gases, which are pollution. So it pollutes the earth.
Okay. So you can't just take a big pile of gas in the ocean and burn it and think that it's gone forever. It's really turns into polluted gases.
Yeah.
Okay.
So, and
Which is important for everybody, like scientists, to know. Otherwise, you could destroy the earth just trying to burn garbage, I guess.
yeah.
Yeah.
Do you have any other questions?
No, but I can see how it. Well, I don't know, but I can see how it would relate to the real. How this would relate to scientists, hundreds of years later.
Yeah.
Trying to preserve the earth and how it's important to recycle and to learn more about conservation of mass. Yeah.
Thank you.
You're welcome.
Okay. See you for the third attempt. Looks like his